Hi, what's up? Welcome back again on this third part of this video. That will be the last part, in this exploratory data analytics with R. Okay, we're gonna continue where we stopped earlier. Um, Alright, let me create a new chunk here, like real quick. And what we're going to do here is we're going to look at the relationship between grade and gender, right? We want to look at how female or male are performing, in the data set, right? Let me create something here. Gender and grade, right? Let me just say something like this: gender and grades. Okay, cool. So I want to look at the relationship between gender and the grade. All right, so the first thing I want to do here is to create a table, right? A proportion table between gender and grade. So first thing you want to do when you want to create this, first of all, is to create a table, right? Between what? Gender. So again here I needed to attach the data set so I can use the data easily. Let me do that to make it easier, right? Let me attach yeah, so let me attach my math placement wherever here, and then I can use table between gender and gender is here and rank, right? So yeah, I'm gonna use the relationship between gender and grade, sorry, not rank but grades, right? So let me run this. That's the table. Earlier I did the table, but this is not what I want. I want a proportion table, right? So these are the two gender, male and female. Okay, so when you over here, the A is like 22 male have scored, A, only one female have scored, and then female have scored 9. So you have 9 female that score A, 22 male have scored A. Okay, when you come to A minus, okay, 6 male have scored A minus, and then female you have 11 of them that score A minus, and so on. Okay, that's the table. Now I do not want the table. I do not want a table. I want like a proportion table, right? So the proportion will give you a percentages, of each of them. So to do that, after creating the table, you come down here to proportion, right? Yeah, so we come here to proportion table, right? It's right here, the function. So we want to create a proportion table of the table that we have up here. So you just pick the table and then you create a proportion of it, and that's what we have here. So when you look at this proportion table, it tells you that 20% of the male, they score A, right? And then 8% of the female have scored A. Okay, it tells you that 5.6% of male have scored A minus, and then 10% of female, and so on. It goes down the ladder, right? The D plus, it tells you that none of the male have scored D plus. Okay, female is like 0.9% of them have scored, and so on, right? So that's what you have here. So we have a proportion table of the grades. Now we can create like a function here, and then we will call it, let me call it proportion table. Okay, I will call it like P table or prop table. Let me call it P table, right? Create a chunk here. I'm not a chunk, but I will create a function P table. So yeah, I call this P table, so I can call on it at any time. So when I come down here and then I say I want to see P table, I can have it at any time. So P table is here, and then when you run it, it's going to give you the proportion table like the one we have earlier, which is cool. Now what I want to do is to plot a graph that shows the relationship, right, between gender and grade. We see clearly, in the graph, a very nice graph. Okay, a bar plot actually, 100% stack bar plots, that's going to show you the relationship. So I'm going to construct, a 100% stack bar, a bar chart, of gender and then grades. So I think this is something that would be very nice to look at, because this is too much. When you look at the percentages here, it's a lot of information to digest, right? There is a saying that say that a graph is worth 1,000 words, right? So when you look at the graph, it's worth 1,000 words. So based on that, let's just look at the stack bar here, to see how we can go about it. So let me build a graph here. Okay, I call it graph. graph. You can say graph number 1 because I might come up with another graph. Who knows? I don't know. So let me call it graph, and then I'll have bar plot. Okay, we have this function here, bar plot, and the relationship between. I already have a table. I want to use this information right here that I call p table. So I'm gonna use this information p table, right, to build my plots. Okay, and I give it a title, and then the title is main, right? How am I gonna call it? I will just say relationship between gender and grade, or I will just say gender grade relationship grades, gender and grade. That's it. I don't want to make it more complicated than that. Gender and grade is more than enough. XPD, yeah, it's right here. Cool. I'm gonna say false. Okay, now you can have all these detail on, on help. When you come down to help here, you put whatever you want. You put bar chart. Okay, you can put bar chart, and then when you whatever I'm doing, bar plot, sorry, bar plot here. So you have all this information here. If you don't understand anything, you have all of it here. Anything that I'm typing in, column, main, excellent, everything is inside here. You can have a detailed explanation of, the meaning of each and every one of them that I'm using here. Every code, is well detailed here. So you go to help, you type in whatever you want, any function, and then it's gonna pop up, and you read, and then you educate yourself, right? So whatever I have here, you can have it there. So yeah, this is what I'm trying to do here. Let me run this piece of code, and there we have it, right? This is it looks great, right? So you have the grade here, you have the gender, right? And then this is what we have here, A. So we have the A minus, B plus. You see, this is amazing. Like the saying goes, right? A graph is worth thousands of words, which is true. So the legend here, it says, clearly you can see I run a legend which say row names of, p table, and the row names of our table here, we have two, right? It's grade and gender. So 0 is male here, 1 is female, right? And clearly you can see here we have more male than female that score A, right? When we come to A minus, female have scored more A minus, right? When we come to A plus, actually it's literally only female have, A plus, male did not have, technically. But when you come down here to B, male have higher B's than female. The same goes to B minus to B plus. So over all the B's, male have the highest B's. Clearly what you can see. When you come to C, is the same thing. Male have higher C score than female, right? Whether it's C minus, C plus, male have the highest score than females, So yeah, that's what we can have, when as regard, to the bar plot is very interesting, when you come with the proportion table, you can plot this and it looks amazing. Clearly you can see, right? I wonder what I can come up with again other than this. We are exploring our data. I don't know. Can we come up with something else? Yeah, maybe a box of plot. Yeah, I can maybe come up with a box of plot here that will help us see because box of plot is very interesting when you have a continuous data and then a categorical data. So when you have a continuous and a categorical data, then you can use a box of plot. Like say I want to look at the score of male, compares like male and females SAT score or SATM score or whatever score they have, based on gender, and see like whether females perform better than male when it comes to like SAT or SATM or ACTM or whatever score you want to look at. So a box plot can make it easier to do something like this. Putting in here a chunk, and then you will see what I'm saying right now. Let's do this real quick. Okay, box plot, right? Box plot, we want to look at let's say SATM, right? SATM score, like SATM, like a score of based on gender, right? So I want to look at the various score, categorical score, based on gender, right? So let's look at the box here. See what I'm saying here? So here you have cause anyway, you already know, right, that this one is male and then this one is female, right? And that's the score that we have. The line here is the median. The line that you have, this dark line inside is the median, right? Split the data into You already know the median, what the median does, right? Split the data into two, right? And clearly you can see the upper side is lower than the lower side, right? So that means highest score are above the median. It tells you that actually very few have higher score as the top, the bottom, like the lower part of these of the median. These are very lower score than the upper. And now the median, clearly when you look at the median, is above six. It's like 66 or something like that. And we can have it here in the summary statistic. We already have a median of, I think it's SATM. Yeah, SATM. So when you look at SATM, the median is 64, exactly 64. So over here, anyone below this have a score lower than 64. So you will see that very few have a score higher than 64 actually. So which is here. So anything here is called outlier. So here this is an outlier. It's a very few. We have very few outliers. So much of the score are concentrated right between 50 I would say 75. Most of these scores are concentrated between these two, right? 50 and then 75. So yeah, that's what we see here as regard this this group, this gender, which is male, right? So when you come to female, clearly you will see something very very the box of plot is something that we cannot even see actually. It's kind of very few have it tells you that like female, this group of people, they have a very low score, right? SATM score, of course, is not overall score because we are dealing with SATM here, right? So this group of students, which are female, they have a very low SATM score. But over here, they have higher SATM score. You clearly can see they have score higher between 50 and 75. But over here, they have a very low score, which is like about like 10. I mean, actually, it's even below 10, actually. They have a very low score when they did not perform well. This group of students, actually. And what else? We can change it. Okay, we can switch. Instead of looking at like SATM, I can look at PSATM actually. Okay, so I can do the same here, but look at something else, right? So let me put another code here. Okay, let me put something different. Okay, let me put a chunk, right? Okay, cool. So let's say I don't want to look at SATM, but PSATM, right? And then let's see based on gender, but still the same thing though. We have a pretty much lower score here than the other one. So what else can I look at other than PSATM, SATM, maybe ACTM? Okay, ACTM, right? So let's change these to ACTM, right? See what we have. Great. So here is the score, right? Because the scores are different anyway, but still it varies here from 0 to 35, something like that, right? The highest here is 35. But when you come down here, this group of students, they have like a score between 0 and 5. I mean, it's not even up to 5, below 5 anyway, below 5. Whereas this group of students, they have a score between the lowest here is 10. This is an outlier, so I don't want to put this into context. So I would say something like 17 and 35, above 35. So between 17 and something like 40. See, so they have a much different score, this group of students. Like there is a group of students that perform better than the other group, right? That's what we see here. And I think the male perform better than females. Yeah, so that's what we have here. And clearly we can see even with this start grade, when we look at the overall grade, you can see that there is a group of students that is performing better than the other group, like the group, the dark, the group of 0, which are the male. Clearly, you can see the male, they have a much higher grade than female. But when you come to the lowest grade, like D, you see that there is no male that actually scored D, right? It tells you that they have a much higher score than female, clearly. And that's what we see here when we come to gender and SATM. We see the SATM score, male have the much higher score. When we come to ACTM or PACTM, male have score higher, than female. So yeah, that's what we can say here. I don't want to go further. I think we've explored we've went through a lot, when it comes to exploratory data analytics here. Now if you want to explore further, I will share the data with you, on this post. so you can explore further on your own. Thank you for watching this video, and yeah, see you on the next one.